Hi, Algebra 1 friends. We are in Chapter 10. We're looking at Section 10.1, and we're going to be graphing quadratic functions. So, our vocabulary reminded me of something, and so I started my little thought bubble over here. You guys remember linear equations? It seems like it was ages ago. Y is equal to 2x minus 3, or linear functions, and you would graph it by creating an XY table. One way of graphing is to do it this way, where you just choose some X values, plug it in, and you get your corresponding Y value. So while you guys were doing whatever you were doing, I was doing this. So 2 times -1 is going to be a -2. -2 minus 3 is -5. If I plug 0 in for X, you'll see that the result will be -3. Check it if you like. And when I plug 1 in for X, you'll see the result will be -1. And then you know what we would do with this. We would get our X and Y axis, something like that. And then we would plot these points. So this is 1, -1. So there's a point down here. And then there's a point here at 0, -3. So it's 0, -3, maybe down here. And then at -1, -5, which I'm going to just say is going to be down here. Let's say this is -1. Right? So we have this situation, and every time we do it, when we're dealing with a linear function, we get ding, 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 a line, right? And so that's been cool, satisfying, and everybody expects it. And of course, I know you all know how to graph this by looking at the slope and the y-intercept. Why am I talking about this? Well, I'm talking about this because today we're going to be talking about something different, which is the quadratic function. And so the quadratic function is going to come from this equation. Y is equal to ax squared plus bx plus c. This is going to be the quadratic function, and the shape that you get will not be a line. And you know, we've been dealing with quadratic equations and such, and you know that they are more complicated than linear equations, so it should not be surprising that you don't get a line. The fact is, when you graph a quadratic function in this form, you are going to get something called a parabola. A parabola is a U-shaped figure that looks something like this. I'm just going to draw that as neatly as I can, and that's a parabola. I kept going too far. I know you guys are disappointed. I know you guys are thinking she should have left well enough alone, but I tried to darken it there. So this is what a parabola looks like. So I'm going to just underline the word parabola so you know that's what we have. And parabolas, typically when the equation takes this form, will generally take either of 2 shapes in general, okay? And so the one shape, excuse me, babies, that you see there, allergies are real, and an upside down parabola. So you will hear me talking about parabolas as happy parabolas, you get Y, and sad parabolas, right? So that's a happy parabola, and this one is a sad parabola. And so why do I talk about them that way? Well, it's just a good descriptive. It's definitely not mathematical, but it kind of helps as I think through the problem and as I help you guys think through what the parabola looks like. So what have we learned so far? We know that quadratic equations, or quadratic functions rather, will give us a quadratic graph, which we will call a parabola. When you have a parabola, and you see the 2 types that we can have, they can be either happy or sad, you will have what we consider a minimum, meaning the lowest possible value. That's going to be right here at this bottom point. That'll have another name in a second. And we have a maximum, which would be only when our parabolas are, in a sense, sad parabolas or upside down. So I mentioned to you before that these points have more than the name minimum or maximum. They're actually called vertices, or the vertex of the parabola. So I'm going to highlight both of those. The vertex of the parabola is kind of like the folding point. It's kind of like the I don't know, the mountaintop or the deepest valley point. It is the minimum or the maximum point in terms of the value. So when we talk about minimum and value, let me just be clear. When I'm talking about minimum and maximum value, I'm really talking about the Y value. So whatever the Y value is here, that's going to be the maximum for this parabola, and whatever the Y value is over, well, I guess I made them at exactly the same spot. whatever the y value is over here. I lost my vertex. Whatever my y value is over here, that's going to be my minimum for this particular equation. Are you guys with me? Does that kind of make sense? I hope so. So that's how I want you to think about that. But the vertex is actually an ordered pair. It's a point. Your vertex will be an XY point. So just a little bit of clarity. Symmetry. You know what symmetry is? It's the quality that if you what's happening on one side is happening on the other. There's a place where you can fold the thing in half, and you have what we would call a line of symmetry. So symmetry is the quality. Axis of symmetry is the thing that I'm drawing here in orangey red. So this is the axis of symmetry. And the axis of symmetry is an equation. It is x equals whatever that value is. X equals whatever this value is. Let's say that's C, and let's say this is D. The axis of symmetry here would be x equals D. The axis of symmetry here would be x equals C. I know it's a lot to process. Hopefully that made sense. Copy down the notes as best you can, and let's get started with some examples. So one thing I want you to take away from this lesson, and basically anytime you have an equation, is that if you have an equation, you're equating or setting equal to one another two different amounts, you can always create a table. You can always create a table, and usually you pick your x values. Since they are the independent values, you pick them kind of randomly and you plug them in, and then you're going to get some ordered pairs. So I know y'all don't really want to see me graph this, to be honest, right? Let's just be honest, but I'll do it because I know that's what I'm supposed to do. So let's go ahead and graph it. So we are given that we have this equation. And so the table of values are created by choosing some values for x, let's say -2, -1, 0, 1, 2, 3, 4, all the way up to 4, and then plugging them into the equation. So you can, that has been done for us, because I know that would take us a mighty long time. And so now it really is just a matter of plotting the points. Now here's what I need to check out. I need to make sure that since I know I'm dealing with a quadratic function, I know that I should have some kind of a parabolic shape. I should have this shape. By the way, these aren't V's. If they look like V's to you, I'm sorry. And they're not exactly U's. They're kind of a cross between a U and a V. All right. So when I have that, I know that I'm going to get the shape. What I want to look for is a turning point. I want to look for the values to either be going down, 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 then they go up, or up, 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 and then they go down. And so I'm going to do that here as I plot my graph, just making sure that things make sense. So at -2, I'm at +11. Let's say +11 is here. And you can already see I started off poorly because I said, let's say it's there. Let me try to be a little bit neater. Okay, that's a little bit better. Let's try to be neat, right? So -2 goes to 11, and so I'm going to put that point up here by the 11. -1 goes to a +1, which is just down here. 0 goes to -5, 2, 3, 4, 5, which is right here. 1 goes to -7. Let's make that 5 a little bit more clear. -7 is going to be right here. 2 goes to -5, and aha, we see the bend. We see a turning point, right? 3 goes to 1, and we're also seeing some symmetry, which doesn't always happen when we choose values, but it's nice when you notice it. It's nice when you can see this perfect symmetry happening. All right, so now I have enough points to basically get the shape of my parabola, and there it is. So the first thing you want to do when graphing a parabola in this form is you want to choose some x values. Make sure when you're choosing your x values and plugging them in to find the y values, you see a turn. Notice 11, 1, -5, -7. It was going down, then it turned around and it went back up. All right. So this particular function is going down, and as a way of talking about this, what I want to do is make sure you guys are really clued in on the fact that we choose values for x, then we plug them into our equation and see what the corresponding y values are. So for a problem like this, you would choose some values for x, -1 all the way up to 5, and then hopefully we'll see a curve or a change in value such we're going in one direction or another, then we have an idea of what's going on. What I want you to observe is that there is a negative in front of this particular function. That's going to be significant. Notice that this value here, I'm going to call it the a value. So y is equal to ax squared plus bx plus c. Here's what I want you to know. This a value, as long as it's positive, you're going to have a happy parabola. But as soon as the a value is negative or less than 0, you're going to have a sad parabola. And so we see that we have that very characteristic here with this function that the title says it's going to be graphing open downwards, or a sad parabola, right? So if I plug in -1, let's make sure we know how to do that. -1 quantity squared plus 4 times -1 minus 1. So what is that going to give me? Here, this is actually going to be a -1 because -1 squared is +1, but the negative is on the outside. So this is -1 minus 4. 4 times a -1 is -4 minus 1. And so when I do this, you would expect my answer to be -6, all right? And so we're going to do that for each of these. When I plug in 0, which is always my favorite to do because boom, gone, gone, you should expect this to be -1. When I plug in a +1, we're going to have a similar experience here, except we're going to see that when I plug in +1, this still is negative, but this would be positive, and that's going to be negative. And so with that, we're going to get a +2. -1 plus 4 minus 1 is going to be +2. And I'm going to stop there. I think you guys understand what substituting means. And so if I substitute in 2, I'm going to have 3. 3, I'll get 2. 4, I'll get -1. And 5, I get -6. And so notice what we had. We've got that turned down. We see that we were going up -6 to -3, to +3 rather, and then from +3 we went back down. And so we'll graph that just like we did the last one, by making sure we have a relatively neat pair of axes and just plotting the point. So here's -1, -6, here's 0, -1, here's 1, 2 up here, and here's 2, 3 all the way up here, and then we got our turning point, 3, 2, 4, -1, and then 5, -6. So we're back down here again. And so there's our parabola. There we go. That other side didn't look too good, but whatever. You guys get me. All right, excellent, excellent. And so this is what's going on when we graph. So again, very straightforward. Plug in some numbers, see what the corresponding y value is, look for a turning point, and then graph. One thing we talked about was the idea of an axis of symmetry, but how do you find it? So what this key concept is showing us is that if you have an equation in the form y equals ax squared plus bx plus c, then the axis of symmetry would be x equals -b over 2a. I want you to put this in your notes. I want you to hold on to that information, okay? All right, let's see if we can apply that to some of the problems coming up. So here in example 3, we are asked to consider the graph of this particular equation. Couple things. What do you know right now, just looking at the equation? All right, so you know it's a parabola. It's either happy or sad. Anybody else? Raise your hand. You back there. Yes, yes, it's an unhappy parabola because of this negative value. We talked about it. I love when kids pay attention. Great. So now we're going to consider it by following these few things. We're going to write an equation of the axis of symmetry, and I just showed you that x is equal to -b over 2a, and so the axis of symmetry is x equals, what's -b? The b term will actually be a +6 over 2a, which is 2 times -3, and so that leaves us with x is equal to -1 rather, and so that's where our axis of symmetry is. Why is that helpful? I don't know about you, but whenever a teacher or somebody says, hey, pick numbers and just plot them, see what happens, I feel a little uncomfortable. So having the axis of symmetry anchors me right to the center of my parabola. So this is good information. So we're going to use that. Find the coordinates of the vertex. Well, this is easy because let's think about it. Let's go back in a little thought process. So if this is the axis of symmetry here, let's use a different color. If this is the axis of symmetry, we know that the vertex has to be on it somewhere. So I know that the vertex has an x value that is the same as the axis of symmetry. Yes. So the only thing I have to do really is find y. So -1 y is what I'm looking for. Now the question is, how do I find it? Anybody know? You kid in a bit. Yeah, plug in -1 into the equation. My babies are thinking, okay, you see I'm having like a little bit of a hallucinatory situation going on. Just stay with me though. So I'm basically using the information that I've been given to find what I need. I need the vertex. I know the axis of symmetry passes through the vertex. Therefore, the x value of the axis of symmetry is going to be the x value that I'll plug into the equation in order to find the corresponding y value. So when we do that, not too much work here, we find out that y is equal to, this is -3 plus 6 plus 4, or basically 10 plus -3, which is a +7. So now I know where my vertex is. My vertex is at -1, 7. Such good information. So I've got the axis of symmetry, I got the vertex. Identify the vertex as a maximum or minimum. Well, clearly, since we know that this is an unhappy parabola, it does not have a minimum, but it does have a maximum. So the maximum is what we're dealing with here. And so y equals 7 is the max value of this function. So identify the vertex as a max or minimum. We did it, and now we need to graph it. So that information that we have is so super helpful because it really does isolate. I'm going to show you how fun this is going to be. Remember all those points that we had to find before? Not anymore. Watch this. So I'm going to go back to the table, but it's not going to be as intense as the last tables that we were doing. So here's my table. I know that I'm dealing with x and y. The first point that I'm going to put here is going to be -1, 7, because that vertex is everything. It's everything. And now what I'm going to do is, and you're going to be impressed, I'm not going to get like 9 or 10 other points. I'm just going to get 2 other points. Yes, I said it, just 2. So watch this. I'm going to get 0, figure out what that point is, 0 and something, and then like 1 and something else. If I can get these points, I think I'm going to be good to go, and I'm going to show you why. We remember that the axis of symmetry is at y equals -1, right? Let's go ahead and draw that in there. And we remember that the vertex is down at or up at -1, 7. So let's put that point on there in green. So let's call this 7. I know I'm being a little free with my points. Just stay with me, chablitos. And that's -1. So -1, 7, there's my vertex. Here's the thing. All I need to know is what's happening here and here, and then I can map it, exploiting symmetry, on the other side. You like it, don't you? I do too. So if I plug 0 into the equation, let me go back and find my equation. I got too excited. If I plug 0 into this equation, right, I'm going to have -3 times 0 squared minus 6 times 0. Oh, wait a minute. I love plugging 0 in because everything goes away except the constant term. So when I plug 0 in, I get 4. That's 1 point. Okay, cool. Let's get this next point. When I plug a +1 in there, I'm going to go right back up here. I know I can erase this stuff that I write all crazily and you guys can't. I'm sorry. But stay with me. So I'm going to plug a 1 in here. 1 squared minus 6 times 1 plus 4. This whole thing is -3. This whole thing is -6, and this is a +4. And so this ends up being -9 plus 4, which is a -5. So I got my points. I've got my points. And watch this. Look how fun this is. I'm going to come down here. This is like 5 here, and this is going to be like -5. And therefore 4 is going to be like right around here. So let's say this is 4. Something like that. I'll make it big so it looks better. And then here we've got our last point at 1, -5, right? +1, -5. So that's 0, 4, -1, -7, 1, -5, and then boom, BIP. This is me exploiting symmetry. So at -2, I'm at +4, and at, let's move this, -3, I am over here at, let me make it better, at -5. And I'm having difficulty with this, but you guys get what I'm trying to do. And so I'm going to put it right there. That's -5 down there. And I have a beautiful parabola with very little work. We're going to talk about the steps one more time. Let me make this so that you all can see it a little bit better. So if we go back up, the first thing we did, we considered the graph by thinking about what it looks like. We decided just from the looks of this thing that we had an unhappy parabola. We found the axis of symmetry using this formula. Then we went back and we found the coordinates of the vertex, which was really easy after knowing the axis of symmetry, because that value will be the x value, the x coordinate of the vertex, and then we plug the x coordinate in to find the y. Finally, to determine whether the function was a maximum or a minimum wasn't hard for us because we already knew we were dealing with a sad parabola. Therefore, we had a maximum value at that y value. And then to graph it, piece of cake. Find 2 other points, exploit symmetry, and we were able to rock it. Make sense? All right, let's look at another example. So here, this example is kind of like a standardized test type question. And so the question is, which one of these equations works for the graph? Now, there is something that is called a point, a vertex form of an equation. We'll talk about that at another time. But let's say you had this with the knowledge that you have now. Can you tell if it's a happy or sad parabola? What do you know? How can you figure it out? What I would ask you guys to do at this stage of the game is I would put it in y equals ax squared plus bx plus c form. That's because this is where we are. This is what we know. So then that would require isolating y, x plus 1 quantity squared minus 1. FOIL this out, so y is equal to x squared plus 2x plus 1 minus 1, right? And then those cancel out, so I get y is equal to x squared plus 2x. So what can I find out from this? First of all, I know it's a happy parabola, so none of these could possibly do. And remember, when you are taking standardized tests and they're multiple choice, elimination is extremely important. So we've just eliminated 2 things, and that's great. The next thing we need to do is figure out which one of these equations is, which one of these graphs satisfies this equation. And the way we can do it is, you can grab a point and say, hey, does this point fit this situation? For instance, 0. If I plug 0 into this equation, 0 for x, what do I get? I get y is equal to 0. So that tells me that point 0, 0 has to be on this graph. And I look over here and 0, 0 is not a part of the graph. That's one way. We could also find the axis of symmetry, right? The axis of symmetry, we remember, is negative b over 2a. So x is equal to negative b over 2a, where b in this case is 2. So that's negative 2 over 2a, and a being 1. So we have 2 over negative 2, which gives me a negative 1 as the axis of symmetry. And again, that points to this answer, C, being correct, because this axis of symmetry is a positive 1. All right? I hope that made sense. I hope that was kind of fun too. But if not, that's okay. This is the end of the lesson, and I look forward to talking to you soon. Let me know if you have any questions or concerns. All right? Take care, dear. Bye-bye.